Okay, so today we're going to talk about radical expressions. There is one question on STAR every year about radical expressions, and it is really easy to get correct. So I'm going to show you both what you need to get it right on STAR and what you need for your geometry teacher not to yell at you next year. Okay, but the first thing we need to know before we actually do this is we have to know what all these different parts of the radical expressions mean. So what most of you think of when you see radical expressions, you think of square roots, because that's the only thing we've seen before. Okay, so let's talk about some vocabulary, because there is actually a lot of vocabulary and a lot of parts of this thing. The first one here, this symbol here, the check mark divide sign, y'all call it sometimes, this is called the radical, or the radical sign. Okay, so the radical is what a root goes under. Okay, now by default, the invisible root is 2. So you know how we have our invisible 1, so like we have our 1x to the first power over 1? On a radical, the invisible is a 2. So if you don't see a sign, it's a square root. But sometimes they'll give you another number, okay? And that number, so if they put a number on here, like so they put, like, so you see if you look down here, see how this one they have a 5, they have a 4, they have a 6. That number is called the index or the root. So they call it the index or the root. Let's write that more. So the index or the root. And what that tells me is how many of that factor I need to see before I can pull it out from under the radical sign. This will make sense to you in a moment. Okay? So we have our radical sign, which is this symbol right here. We have our root, which if you don't see it, like if you see a symbol looking just like that, your invisible root is 2. Otherwise, it's whatever number they put there. And then we have what's under the radical sign, which is called the radicand. Okay, and the radicand is the number under the radical sign, and that's the number we're trying to find the root of. So like, for example, down here, we have the square root of 27. We have the square root of 36. Here we have the 4 root of 16, the 5 root. We might have a cube root of something, which would be a 3 root. And if we don't know, like so we have square root, cube root, and then anything after that is just the number of the root, the 4 root, the 5 root. And I'm sure there's a better way to say it, but that's how I say it. Okay? Okay, so we have the radical sign, we have our index or our root, and then we have our radicand, which is the number under the radical sign. Now sometimes you'll see an exponent. Well, that's still just called an exponent. Okay? I think it actually has another name, but that's okay. We're going to call it that. Huh? Or the power. Yeah, or the power. Okay, so that's the parts of a radical. Okay, and those are the things we need to understand. Now we've got to understand what we're going to do with them. Okay, so let's really quick, let's write this down because I want this to make sense to you. The root is what times itself n times gives me the radicand. Okay, so what number times itself n times is going to give me the radicand? So if it's a square root, I need some number that I can multiply by itself, the number times itself. It's going to give me that value. Down here, I'm looking for what number times itself gives me 27. What number times itself gives me 36. This one, I'm looking for what number times itself 1, 2, 3, 4 times gives me 16. This one needs something that I multiply by itself 5 times to give me negative 243. Okay, so when we talk about the index, that's telling me how many times I have to have it before I can take it out from under the radicals. So what does that mean? Well, let's look at a couple easy ones first. Okay, the square root of 36. Okay, so if I put the square root of 36 in my calculator, I get 6. Okay, so the square root of 36 is 6. But from a procedure standpoint, when we're actually simplifying square roots, here's why the square root of 36 is 6. Okay, well, I have a square root of 36. I'm sorry, that's a 2. Don't judge me. That's a 2, right? A square root of 36. What times itself is 36? Well, 6 times 6 is 36. I can take those two 6's and move them out from under the radical sign to give me a value of 6. So the square root of 36 is 6 because 6 times 6 is 6. So basically, like a square root is like the opposite of squaring something. Okay? Now, some of you may be saying, Mrs. Deal, it's 6 and negative 6. Well, for our purposes right now, we're only looking at the principal square root. Just for now, okay? Just for this, because we're learning how to do this, we're only looking at the principal square root. But yes, you're absolutely right. It is 6 and negative 6. Okay? Now, what about 100? Y'all should be able to do 100. Okay? And again, I'm going to start with my calculator. Square root of 100. It's 10. I knew that. The reason it's 10 is because 10 times 10 gives me 100, and that's a pair, and since I need 2, I can take those out from under the radical and give me 10. Okay? Now, let's look at something like this one up here, 27. Now, if I put square root of 27 in my calculator, I get this crazy nonsense. So we're going to write down what we see, 5.196. I'm just going to write 5.19615. I know that's kind of crazy, but that's enough for me to see a match, I think. Okay? So what that tells me is there is no whole number I can pull out from under this radical sign that's going to give me 27. So I'm going to have a simplified radical. Now, this isn't it. That's not what they're looking for. When they talk about something in simplified radical form, well, let me show you what they're talking about. So the first step is to prime factor this 27. So I'm going to take 27. I'm going to do prime factorization. Well, 27 is 3 times 9. I circled 3 because it's prime. And 9 is 3 times 3. So if I were to rewrite, let's just write this here. If I were to write the square root of 27, it's got that invisible 2, right? Let me erase this because it looks crazy. The square root of 27. The square root of 27 is 3 times 3 times 3. But I can't take out all 3 of those. I can only take 2 of them because they have to come out from under the radical sign in pairs because I have a square root. Because this index of 2 tells me I'm trying something that I can take out 2 times. So I have to take them out 2 at a time. So here's what I think about them is. I think about like how many of that same value, oh my gosh, how many of that same value, how many sets do I have to take them out? It's kind of like an exchange rate. Like when you go to another country, not that I've ever been to another country, but I understand that when you go to another country, you have to exchange your money for theirs, and there's an exchange rate. Okay, so I'm inside the radical. I want to come outside the radical. Well, I got to exchange 2 inside to take 1 outside. Okay, so this means these 2 I was able to move outside of the radical, but this one I didn't. Well, does this one have a partner? Does it have a buddy that can come out from the radical with it? No, there's just 1 in there, so I have to leave it like that. So before I do that, let's check and see. So I said the square root of 27 was 5.196. Let's put 3 square root of 3 in there. Look at that, I get the exact same thing. So these are equivalent. Simplify is another one of my keywords that means equivalent. And equivalent means I can check these and see if they give me the same value. On STAR, this is what you're going to do. You're going to get the question right every time. In geometry, they're going to expect you to give them this answer. Okay, that's a great question. So Ms. Schultz just said, can you specify why we put 3 on the outside and not 3 times 3? Because I'm exchanging these 2 inside. So remember, it's that exchange rate. So I'm saying, in order for me to pull 1 out, I have to have 2 in. There have to be 2 inside for me to pull 1 out. So when I took these 2 3s on the inside, and I exchanged them for 1 on the outside. So that became 1 on the outside, and then I still have that 1 left over on the inside. Okay? So let's just take a look at a couple more. All right, so let's look at square root of 32. Okay, we're going to jump around a little bit. Okay, so I'm going to start by doing prime factorization. First of all, I see that I have that in. Oh yeah, actually, Ms. Schultz is right. I should put that in my calculator first because ABC people always be calculating. Square root of 32 says 5.65. Okay, let's write that down. 5.65685. Now, we both know that on STAR, you're already going to have that here in your calculator. But let's do some prime factorization. Well, 32 is 4 times 8. 4 is 2 times 2, and those are prime, so I can circle them. 8 is 2 times 4. 4 is 2 times 2. Good Lord. Okay. So 32 is 2 times 2 times 2 times 2 times 2 because I had 1, 2, 3, 4, 5 2's. Okay. Now this is a square root. So I have to exchange 2 on the inside for 1 on the outside. Now I can do that twice. So I have a 2 and a 2 on the outside, and I have another 2 on the inside. Okay? Now I'm multiplying them. So when I move stuff outside, if I've got more than one thing outside, I multiply. If I've got more than one thing inside, I multiply. Okay? I'll give you an example of that in a second here. Okay? So the one here, I'll do an example. This is the example. I'm going to write it down just so I don't forget it. Right? We're going to do 540. Okay, and I'll show you what that is in a minute. You're like, oh my God, Miss Dill, have you lost your mind? Maybe I have. I don't know. Let's find out. Okay, so when I multiply my 2 times 2 together, I get 4 square root of 2. Well, let's put 4 square root of 2 in our calculator. Just pretend I didn't see that. Okay, so 4 square root of 2 gives me the same number, so I know that I'm right. Okay, so let me give you an example of one where you got to multiply stuff inside and outside. Okay, so first of all, I see this is a 2 root. I'm going to put square root of 540 in my calculator, and I get 23 point, let's just say 2379. 23.2379. Okay. All right. So now I'm going to try and factor this thing. Well, I see 54 times 10. 10 is 2 times 5, so I feel pretty good about that. 54 is 6 times 9. 6 is 2 times 3. 9 is 3 times 3. And those are all prime at this point. Okay. So now I'm going to rewrite this with all of these numbers underneath my radical sign. Oh my goodness gracious. I'm going to try and organize them a little bit though. So I have 2 times 2 times 3 times 3 times 3 times 5. Sorry, I had to write that small. Okay. 2, 2, 3, 3, 3, 5. Okay, so now my exchange rate is 2. So I see 2 2's that can come out from under the radical. I see 2 3's that can come out from under the radical. And I see 2 more numbers. But are they the same? No. So they can't come out from under the radical. They got to stay there. Okay? So I have 2, because those 2 2's exchanged for 1 on the outside. These 2 3's are going to exchange for 1 on the outside. And the 3 and the 5 have to stay under there because they don't have partners. Okay? So now I'm going to multiply the outside and multiply the inside. Gives me 6 square root of 15. And let's just knock on wood that I did this right, y'all. 6 square root of 15 gives me the exact same thing. So I know that these two things are equivalent, and I've done it correctly. Okay? Let's talk about a couple of other things really quickly. And again, we'll talk about this more in class. All right? This is kind of to whet your appetite. Let's take a look at this, right? Let's take a look at square root of negative 25. Okay? Square root of negative 25. Okay? When I put that in my calculator, I get error, non-real answer. And when I click go to, it's like square root of negative 25. Like, what's that? You can't do that. The calculator is very upset about that. Okay? So, just for the heck of it, so I'm going to write undefined. Because officially, that's what the answer to square root of 25 is. It's undefined. Now, just for the heck of it, let's try the 3 root of negative 25. Now, how do I do a 3 root? Let me show you. I'm going to hit math. And you can do 4 for the 3 root, or you can just jump straight down to 5, and that'll let you pick whatever root you want. Hold on. Nope, that's not it. Math, root there. Now, it says answer. I don't know why it's doing that. But I'm going to put the 3 root, so I'm going to change the index with whatever number I want. I'm going to put negative 25 in there. Well, hey, look at that. It gave me an answer. I'm going to write negative 2 point, I'm just going to write 2.92. Okay? Let's try the 4 root of negative 25. So I'm just going to arrow up there, and change that 3 to a 4. Uh-oh, I got undefined again, non-real answer. Okay, all right. Let's try the 5 root. Okay, that worked. The 5 root of negative 25 gave me negative 1.90. So, what do we notice about the ones that were undefined? What do we notice about their index? Well, their index is even. Meaning divisible by 2. Okay? Well, let's just make another number up. So let's pick another number that's divisible by 2. So let's see, 32. That's divisible by 2. Didn't work. Gave me an error. Okay? So when the index is even, I cannot take the root of a negative number. Now, these have an odd index. Meaning they can't be divided by 2. So let's try an odd index. Let's just pick, let's say negative 37. Gave me a number. Okay? So when I have an even index, I cannot take a root of a negative number, but when it's an odd index, I can. Okay? Last thing I want to show you is, I don't really want to show you, but the 4 root of 16. So let me go up here. I'm going to just borrow this 4 root. The 4 root of, 4 root of 16 gives me 2. Why did that happen? Because this time, when I do my prime factorization, this is a 4 root, okay? So I have 2 times 2 times 2 times 2 gives me 16. Well, a 4 root tells me, instead of taking them out from under the radical in 2's, like I was doing, now I got to have 4 under the radical to exchange for 1 outside. For this one, I would have to have 5 of the same number under the radical, 6 for this one, 10 for that one. Okay, we're going to talk about this more in class tomorrow, and we're going to practice it, but your ultimately, every time you do one of these problems, you're going to start by sticking it in the calculator. And then if you don't get a whole number, then you're going to jump to trying to do prime factorization on star. We're not even going to do that.